Hello my friends and welcome back to the You Can Do TV channel. The Super Strip Cable Stripper revolutionizes the process of recovering copper from cables and wires by providing a more efficient, environmentally friendly alternative to traditional methods like burning and melting. This innovative machine is designed to separate the copper core from its PVC or plastic sheathing, ensuring that the recovered copper retains its shiny, bright finish, ideal for maximizing its value. The Super Strip can handle a wide range of cable sizes, from thick wires up to 32 mm to thinner, more intricate cables, including problematic wires that are challenging to process manually. Users simply select the appropriate cable size guide, adjust the cable feeder, and the machine does the rest, automatically stripping the PVC coating and separating it from the copper. Equipped with a reverse action feature, the Super Strip ensures smooth operation. If a wire gets stuck, a simple switch reverses the mechanism to resolve the issue effortlessly. It also processes the removed PVC as scrap, creating an additional revenue stream, while eliminating waste and adhering to environmental regulations. Capable of stripping up to 3 times more cable per day compared to manual methods, the Super Strip significantly boosts productivity and profitability. The machine is robust, powered by 380 volts, and includes spare fan belts and blades for long-term reliability. This ensures sustained performance in producing high-value copper. Stage 1. Dismantling and housing removal. The process begins with dismantling the electric motor by removing external parts and attachments. Once the outer pieces are unscrewed, the motor housing, either aluminum or cast iron, is exposed. Using a high-pressure splitting apparatus, the housing is cut on opposite sides and peeled away, exposing the internal rotor, which is then removed. Stage 2. Stator splitting. In the second stage, the stator, or transformer block, is cleaved into 2 equal halves. This action opens up the stator and exposes the copper coils embedded within, preparing them for separation. Stage 3. Copper separation. The final stage involves extracting the copper wiring from the stator. A hydraulic pulling system is used to pull the copper coils out from the surrounding metal. This leaves behind a clean pile of copper wiring and recyclable scrap metal. This streamlined process ensures maximum material recovery, with clean separation of copper and recyclable metals, making it a profitable and sustainable recycling solution. The radiator recycling machine is designed to process various waste radiators, including AC radiators, condensers, and industrial radiators. This production line ensures efficient recycling and clean separation of valuable materials. The process begins with a feeding conveyor that transports the waste radiators into a high-speed vertical hammer mill crusher. The mill not only crushes the materials but also rubs and fluffs them, preparing them for effective separation. After crushing, the materials pass through a magnetic drum, which removes iron components. The remaining crushed radiators are then screened into 2 to 3 size categories to enhance the efficiency of the final separation. The critical final stage involves separation using either a blower or density separator, ensuring clean separation of copper and other materials. The QD600 SAW copper wire recycling machine is an advanced medium-capacity system designed to process 400 to 800 kilograms of waste wires and cables per hour. It operates by breaking down and separating valuable copper from mixed materials with high efficiency and minimal environmental impact. The system begins with a feeding conveyor that delivers waste wires and cables to the integrated QD600 shredder. The shredder cuts the materials into smaller pieces and uses a belt or drum-type magnet to remove any iron components. This pre-treatment protects the blades of the main crusher, extending their service life and improving overall performance. Once shredded, the processed material moves to the main crusher, where it is further granulated. An air separator and dual vibration tables then work to separate copper from plastics and other non-metallic components. The machine achieves a separation rate of up to 99%, ensuring a high yield of pure copper. The machine is versatile, handling car cables, Ethernet wires, small transformers, and more. With its robust design and enhanced capacity, the machine provides efficient recycling, maximizing profitability while reducing maintenance issues. The copper chip briquetting plant, featuring the 900 EVO briquetting press, is a state-of-the-art solution designed for recycling metal shavings from mechanical processes. This innovative hydraulic press compacts loose copper chips into dense, cylindrical briquettes, offering numerous operational and environmental benefits. The process begins with the collection of copper chips, which are optionally shredded to ensure uniformity. The material is then fed into the 900 EVO briquetting machine. The hydraulic system applies extremely high pressure to compact the chips into cylindrical briquettes of adjustable diameters. These briquettes are discharged and ready for storage, transportation, or direct use in melting furnaces. Key advantages of this system include up to 90% reduction in chip volume, enabling efficient use of storage space and reducing handling and transport costs by 80%. The compact form of briquettes minimizes environmental pollution and increases their commercial value by 50%. Additionally, melting yields improve by 90% as briquettes minimize oxidation and energy loss during melting. The plant also recovers up to 20% of valuable cutting oils during pressing, significantly lowering operational costs. The robotized copper anode handling system is a sophisticated automation solution designed to enhance efficiency, precision, and safety in industrial operations. This system employs an industrial robot to extract copper anodes from a casting turntable and transfer them to designated areas for cooling, storage, or further processing. The integration of advanced robotics ensures seamless operation within the production line. The system is meticulously designed using advanced simulation tools to guarantee compatibility with the plant's operational demands. This design process includes the development of customized grippers to securely handle the anodes, robust sensors for accurate positioning, and an intelligent control system for smooth coordination with other equipment. These features enable the system to adapt to varying production requirements and handle anodes of different sizes. During operation, the robot identifies the position of the anode on the turntable using either vision systems or pre-programmed coordinates. It then uses a specialized gripper to secure the anode without causing surface damage. The anode is transported with precision to its next destination, such as a cooling station or storage rack. The system operates continuously and efficiently, keeping pace with production demands. This automated solution offers several key advantages. It significantly increases productivity by reducing cycle times and minimizing downtime. By eliminating the need for manual handling near molten metals, it enhances workplace safety. Furthermore, the consistent and precise handling of anodes ensures high product quality. The production of a Bach trumpet involves a meticulous process that combines traditional craftsmanship with modern precision engineering. Each step is essential to creating an instrument that produces the classic Bach sound, renowned for its tonal richness and unparalleled quality. Crafting the bell. The bell of a Bach trumpet begins as a single piece of stamped brass. This initial blank is carefully shaped into the iconic flare that contributes significantly to the trumpet's tonal character. The edges of the brass are brought together to form a seam, which is expertly hammered and sealed using fusion paste. A torch, capable of reaching temperatures over 2000 degrees Fahrenheit, is used to braze the seam, ensuring structural integrity and sound quality. One key to the bell's unique resonance lies in its variable wall thickness. This design feature, developed by Vincent Bach, allows the bell to vibrate freely, producing a sound with remarkable clarity and depth. After brazing, the bell is heat-treated in a process called annealing, which enhances its acoustic properties and durability. Shaping the bell involves a solid steel mandrel, which serves as a mold for forming the precise curves and taper. Excess metal is trimmed, and the rim is reinforced with a wire ring. This additional structure prevents collapse and enhances the bell's responsiveness. The taper, or rate at which the bell widens, is crucial for sound modulation. Fast tapers produce darker, mellower tones, while slow tapers yield brighter, more penetrating sounds. The Bach plant continues to rely on Vincent Bach's original designs, which include over 76 variations of bell shapes for B-flat trumpets alone. Precision tubing and bore size. The brass tubing used in a Bach trumpet undergoes a process called drawing, where a steel mandrel is inserted into the tubing and pulled through a steel ring. This step determines the bore size, or the internal diameter of the tubing, which has a significant impact on air resistance and tone quality. Even minute changes, as small as the width of a human hair, can alter the trumpet's sound. The lead pipe, an essential part of the instrument, converts the vibrations initiated by the player's buzzing lips into standing waves, which are heard as musical notes. Each lead pipe is designed with precision to ensure optimal airflow and acoustic performance. Valve and slide construction. The valves, often considered the heart of a trumpet, are crafted with extreme precision. The valve casings are brazed together using custom fixtures to maintain alignment, ensuring airtight seals and smooth piston movement. The pistons themselves are made from monel, a durable nickel alloy that provides a perfect balance of tight fit and freedom of movement. Once the valve cluster is assembled, it is soldered to the trumpet's tuning slides. The distinctive D-shaped main tuning slide, a hallmark of Bach trumpets, is still manufactured according to Vincent Bach's original design. Additionally, the third valve slide ring, used to adjust intonation on specific notes, undergoes a 7-step fabrication process, exemplifying the attention to detail in every component. Mouthpiece production. The production of a Bach trumpet begins with its mouthpiece. Solid brass bars are precisely machined to create the mouthpiece's shank, rim, and internal contours. Each step is executed with tolerances as tight as 1/1000th of an inch, ensuring consistency and precision. The mouthpiece plays a critical role in shaping the instrument's sound and is a testament to Bach's legacy of innovation. Final assembly and testing. A Bach trumpet comprises over 120 individual parts and undergoes 465 steps during production. Skilled artisans assemble the instrument twice, ensuring flawless alignment and functionality. After assembly, the trumpet is buffed, lacquered, or electroplated to achieve a polished finish. Quality control is rigorous, with each trumpet undergoing multiple tests. The tester checks for air leaks, verifies the smoothness of the pistons and slides, and plays the instrument to ensure it meets Bach's exacting standards. Even the lead pipe's opening and the mouthpiece receiver are calibrated to precise distances to optimize sound production. A legacy of excellence. For over a century, Bach trumpets have been synonymous with quality and craftsmanship. From the initial shaping of the bell to the final assembly and testing, every step in the production process reflects Vincent Bach's vision of creating the Stradivarius of trumpets. Today, Bach trumpets continue to set the standard for excellence, proudly upholding their American-made tradition. Sarkuysan's production process begins with high-purity copper cathodes, which are transformed into a range of advanced copper products using state-of-the-art continuous casting technology. The company operates on a vast production area of 180,000 square meters, with 77,000 square meters dedicated to covered facilities in Gebze and Derica. The primary products include electrolytic copper wires, copper rods, copper profiles, and copper tubes. Specialized products such as oxygen-free copper, tinned and nickel-plated copper wires, and copper-silver alloys are also manufactured. Sarkuysan's unique continuous casting lines ensure consistent quality for high-conductivity copper products used in the automotive, aerospace, electronics, and power transmission industries. Advanced precision machinery produces fine copper wires, multi-stranded cables, and flat wires that meet the stringent requirements of sectors like renewable energy, telecommunications, and electromagnetics. Quality assurance is conducted in on-site physics and chemistry laboratories, certified by the Turkish Standards Institute. The production of copper rods and bars at the expert cable plant is an advanced and efficient process designed to meet high-quality standards. The plant processes up to 800 tons of high-grade copper per month, including MOO and M1 grades, producing oxygen-free copper rods ranging from 8 to 25 millimeters in diameter and soft or hard copper bars up to 250 millimeters in width. The plant successfully launched its copper processing workshop using the innovative upcast continuous upward casting technology. This facility specializes in manufacturing oxygen-free copper rods with diameters from 8 to 25 millimeters. The production capacity of the line is up to 12,000 tons annually. The nominal diameter of the rods is 08.00 millimeters, with coils weighing approximately 3 tons, ranging from 1 to 3.4 tons. Each coil has an internal diameter of approximately 700 millimeters and an external diameter of 1,450 millimeters. Finished products are secured with plastic straps, wrapped in polyethylene, and placed on wooden pallets. Oxygen-free copper rods boast stable chemical composition and high electrical conductivity. With oxygen content below 2 ppm and minimal gas porosity, the risk of cracks in cast and rolled products is significantly reduced. These rods are ideal for high-speed wire production, up to 30 meters per second, and enable the manufacturing of fine wires, 0.15 to 0.5 millimeters, without intermediate annealing, ensuring cost efficiency and superior performance. Fast Cables, a prominent manufacturer of electrical cables and conductors in Pakistan, has been driving innovation since 1985. With a vast range of products including bare conductors, low-voltage cables up to 3.3 kilovolts, and medium-voltage cables up to 36 kilovolts, the company caters to diverse sectors such as telecommunications, oil and gas, construction, and engineering. The manufacturing processes at Fast Cables are centered around state-of-the-art facilities in Lahore, equipped with cutting-edge machinery and technology. The journey begins with the procurement of high-quality raw materials, which undergo rigorous quality checks to ensure compliance with international standards. Copper and aluminum are processed through rod breaking and wire drawing, transforming raw materials into wires of precise sizes. These wires are annealed to achieve high conductivity and durability. In the stranding process, wires are grouped to form conductors with varying cross-sections. This is executed on sophisticated high-speed stranding machines, ensuring optimal resistance and shape. For insulation, advanced extruders are utilized to coat wires with materials such as PVC and PE polymers. Fast Cables has pioneered the use of continuous catenary vulcanization, CCV, extrusion technology in Pakistan for medium-voltage cables. This system employs closed-loop filtered air and X-ray monitoring for precision, ensuring uniform insulation free from impurities. The laid-up multi-core cables undergo inner sheathing through computerized extrusion lines, followed by armoring for added protection. The armoring process uses aluminum or steel wires with a zinc coating to prevent rust and enhance durability. Finally, outer sheathing layers are applied using flame-retardant PVC or halogen-free materials. Notably, Fast Cables manufactures its own PVC compounds in-house, ensuring superior quality and enhanced safety features. Quality control is integral to every production stage. Products undergo stringent testing for conductivity, flame resistance, smoke density, tensile properties, and thermal stability. High-voltage testing capabilities up to 75 kilovolts further underscore the company's commitment to excellence. India has become a global hub for manufacturing high-quality synchronous motors, driven by advanced production techniques and a skilled workforce. Among the leading players in this domain is WEG India, renowned for producing reliable, high-performance motors. Their SDA 1400 to 2240 kW synchronous motor is a testament to India's manufacturing prowess, catering to a wide range of industrial applications with its superior efficiency and durability. The SDA 1400 synchronous motor is designed to deliver exceptional performance, boasting a power output of 2,240 kilowatts and a 28-pole configuration for seamless power transmission. Operating at a voltage of 3.3 kilovolts, it is ideal for medium voltage systems across industries. Its D5 frame design ensures mechanical stability, making it capable of withstanding rigorous operating conditions. Additionally, synchronous motors like the SDA 1400 offer advantages such as higher efficiency, improved power factor correction, reduced inrush current, and consistent speed operation, making them indispensable in industrial applications. At this state-of-the-art manufacturing facility, the production of the SDA 1400 motor follows a meticulous process. It begins with the fabrication of the D5 frame, ensuring a robust structure to house the motor components. The stator core is assembled, followed by stator coil insertion. A key step in the process is the global vacuum pressure impregnation, VPI, of the stator, which enhances insulation and ensures long-term reliability. Once the stator is impregnated, it is stacked into the frame for further assembly. Simultaneously, the motor shaft undergoes precise machining to achieve optimal alignment and balance. The polar wheel is machined and stacked onto the shaft, ensuring accurate integration. This is followed by the pole assembly, where the rotor is equipped with magnetic poles for efficient electromagnetic operation. The final assembly brings all components together, culminating in rigorous inspection and testing under the watchful eyes of the customer to ensure compliance with international standards. Once the motor passes all quality checks, it is carefully packed and dispatched to its destination. For instance, a recent shipment of the SDA 1400 motor was successfully delivered to a site in Australia. Upon arrival, the motor was unpacked, the base frame fixed, and the assembly completed at the site. Under operation, the SDA 1400 demonstrated its exceptional performance and reliability. Dash 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 dash. The copper tube making machine is designed for forming the ends of copper or aluminum tubes used in industries such as air conditioning, refrigeration, and cold storage. It performs operations like enlarging, expanding, flaring, swagging, reducing, necking, and sealing tube ends to meet specific industrial requirements. This machine is available in multiple configurations, including single, dual, triple, and multi-station setups, depending on production needs. It automates the process from tube loading to finished end formation, reducing time and labor costs while enhancing efficiency. Capable of processing 4 tubes simultaneously under unified control, it significantly improves production throughput. Compact in design, the machine occupies minimal floor space, making it ideal for high-volume manufacturing environments. Its automation features streamlined operations, ensuring consistent and precise tube end formation with minimal operator intervention. The production process at Super Radiator Coils reflects a commitment to precision and innovation in heat transfer technology. The process begins with detailed collaboration between engineers and clients to ensure all application-specific requirements are captured, including design constraints, material selection, and installation parameters. Custom designs or adaptations of standard models are meticulously planned and prototyped as needed. Components undergo rigorous performance verification in a specialized wind tunnel and advanced test labs. Manufacturing utilizes high-quality metals to produce fins, tubes, and headers, ensuring maximum heat transfer and durability. Advanced techniques like tube expansion, expert brazing, and welding are employed, followed by thorough leak testing. Custom air coolers are designed for demanding environments and diverse applications, including HVAC, compressors, and nuclear power. This robust process ensures unparalleled quality and reliability for every product. The Jutec Bending System 3000 is a compact and mobile bending machine designed for precise and repeatable performance, whether stationary or on-site. Its powerful motor and precision gear ensure robust operation, while position detection on the bending axis guarantees optimal bending accuracy. The bending angle can be easily adjusted using a set actual value display. The machine is conveniently stored in solid transport cases, making it portable. At the mounting site, its tripod and stationary tube, rotating tool design allow bending in tight spaces. Slide shoes enable wrinkle-free bending of thin-walled stainless steel or copper tubes. With the PB20 adapter, it can also bend flat steel bars, square steel, and round bars effortlessly. The economical bending machine with an electric drive is designed for precise and efficient tube bending, capable of tight radii. Its freestanding bending head can switch between right and left bending for complex geometries. Plug-in bending tools enable quick adjustments for various tube sizes, while fast hydraulics reduce downtime, making it suitable for series production. The PLC control with a data memory and X2 interface supports up to 50 bending sequences per tube and a material database for up to 200 materials to monitor springback. 2 modes: simple bending, for automatic display, and controlled bending, for pre-stored data, minimize errors. Its compact, versatile design suits both mobile and stationary applications. The production of aluminum parts through die casting is a meticulous and advanced process. This technique is widely used in industries such as automotive, power tools, and construction due to aluminum's lightweight, corrosion resistance, and strength. At Metazel, one of Europe's largest and most modern die casting facilities, aluminum production combines state-of-the-art technology with rigorous quality control. The process begins with raw aluminum melted in induction furnaces, capable of liquefying 1.5 tons of material in just 45 minutes. The molten aluminum undergoes purification through a refiner that injects argon gas, removing impurities and ensuring a clean metal bath. The purified aluminum is then transferred to holding furnaces to maintain its liquid state for casting. Using advanced robotic systems, the molten aluminum is precisely extracted with a pipette submerged below the liquid surface to avoid contamination. The liquid metal is then injected into molds under high pressure, filling every cavity. As the metal solidifies, the molds open, revealing the castings. Post-casting, The aluminum parts undergo rigorous inspection using radiographic techniques to identify structural anomalies such as air bubbles or impurities. The castings are further refined through tumbling or shot blasting and then proceed to machining on advanced NC-controlled horizontal and vertical machining centers. Processes like threading, turning, and milling ensure precise specifications. Finally, the finished parts are subjected to stringent quality tests, including measurements with up to 3-micron precision, strength evaluations, and chemical composition analyses. Only after meeting strict standards are the aluminum parts shipped to customers, ensuring reliability and excellence in every product. The system is characterized by high levels of automation, efficiency, and precision, ensuring consistent mold production. Fast loop system. This is the core mold making loop, where sand is mixed with a chemical binder and delivered quickly to the pattern for forming molds. It ensures rapid and repeatable mold production, minimizing downtime. Rollover stripping system and empty pattern return. Once the mold is formed, the rollover stripping system inverts the mold and separates it from the pattern. The empty pattern is then returned automatically for reuse in the next cycle. Mold processing system. After stripping, the mold undergoes further processing, including coating in the coating area and curing in the primary oven and secondary oven, which ensures the mold gains the required strength. Core setting and closing area. In the core setting and closing area, pre-formed cores are placed inside the molds, and the molds are closed using a mold handling manipulator for precise alignment. Pouring and cooling system. Closed molds are transferred to the pouring line using an RFID tracked pusher trolley. Molten metal is poured into the molds in the pouring area, followed by cooling in the cooling line. Knockout process. Once cooled, the molds are transferred to the knockout process, where the sand is separated from the casting. The sand is collected and recycled, while the finished castings are taken for further processing. Dust collection and emergency systems. A dust collector system maintains a clean and safe work environment by extracting fine sand particles. Emergency protocols are in place, including an emergency pouring line panel for quick shutdowns. This fully integrated no-bake sand system ensures high-quality casting production with minimal manual intervention, enhanced precision, and optimized workflow. Northern Iron and Machine Osborn automated tight flask molding machine for iron castings. 147 Northern Iron and Machine utilizes the Osborn automated tight flask molding machine to efficiently produce iron castings weighing up to 250 pounds. This advanced system achieves a production rate of up to 38 molds or castings per hour, offering quick and seamless pattern changes within 60 to 90 seconds. The machine's design ensures straightforward placement of chills and sleeves, allowing for fast adjustments to meet specific casting requirements. Its unique compensating squeeze bead mechanism delivers uniform mold hardness, enabling the casting of intricate geometries. Drilled vents effectively release gases, preventing pressure buildup and ensuring mold integrity. The mold cycle sequence facilitates precise core placement, while cope and drag mold halves are automatically combined and transferred to the pouring line. Pour-ready iron is delivered promptly, with the iron pourer adding alloy elements tailored to part specifications and performing temperature checks to maintain optimal pouring conditions. Mold weights are set automatically to guarantee stability, and the line indexing process is fully automated. This streamlined operation supports the production of high-quality ductile, gray, and austempered ductile iron castings, solidifying Northern Iron and Machine as a reliable source for casting solutions. The casting production process at Chugan Spec-Stroy, located in Lipetsk, exemplifies the advanced lost foam casting technology. This method begins with the design and production of foundry tooling. Models are crafted from foundry-grade expanded polystyrene, EPS. The process includes assembling the mold and filling it with pre-expanded EPS beads, which are then fused in an autoclave to create the model. After autoclaving, the model is extracted from the mold and undergoes precise assembly and bonding to achieve the required shape. Once assembled, the models are coated with refractory paint and dried to ensure surface stability and dimensional accuracy. The dried models are placed in sand molds for casting preparation. The molds are filled with molten ductile iron with spheroidal graphite. During the pouring process, the EPS model vaporizes, leaving a cavity that is immediately filled by the molten metal, resulting in the desired cast shape. After solidification, the molds are broken and the castings are extracted for finishing. The Master Cable Recycling Line is a high-performance system designed to recycle various cable types with a processing capacity of approximately 300 kilograms per hour. It includes specialized equipment such as conveyor belts, shredders, grinding mills, magnetic separators, and a water separator for efficient material processing and separation. The process begins with a single shaft mill pre-shredder, 22 kilowatts, which reduces cable size for further processing. A belt conveyor with a magnetic roller then separates ferromagnetic materials from the shredded cables. The Tornado 630 grinding mill, 18.5 kilowatts, refines the material into uniform fractions, supported by an advanced double dust extraction system for cleanliness. A second Tornado 630 mil, 22 kilowatts, provides additional grinding before the material moves to the Gold River 2500 water separator. This separator utilizes an innovative water system and pressure control valves to achieve precise separation of metals and plastics, even for challenging materials like 15-micron copper wires. The global metal recycling industry plays a crucial role in sustainable development by conserving natural resources, reducing energy consumption, and minimizing environmental pollution. The market is rapidly expanding, driven by increased demand for recycled metals in various industries, such as automotive, construction, and electronics. According to recent market data, the global metal recycling market was valued at approximately $65 billion in 2023 and is projected to reach $100 billion by 2030, growing at a compound annual growth rate (CAGR) of 6.5%. Copper cable recycling. Copper is one of the most valuable recyclable metals due to its excellent conductivity and high reuse potential. Recycling copper cables helps recover 99% of the metal, significantly reducing the need for primary copper extraction. Fine number 1 copper wires are often stripped from shredded wires, ACSR, aluminum conductor steel reinforced cables, and Cat.5 cables, which are commonly used in data transmission networks. The recycling process involves shredding, granulation, and separation, resulting in high-purity copper ready for reuse in electrical and electronic applications. Aluminum cable and radiator recycling. Aluminum cables, widely used in power distribution and automotive industries, are also highly recyclable. Recycling aluminum consumes only 5% of the energy required for primary production, saving approximately 95% of energy compared to mining and refining new aluminum. Radiators from vehicles and HVAC systems contain both aluminum and copper, making them prime candidates for recycling. Modern recycling facilities use advanced separation techniques to recover both metals with minimal waste. Iron and steel recycling. Iron and steel are the most recycled materials globally, with a recycling rate exceeding 90% in many industrial sectors. The process involves collecting scrap iron, melting it in electric arc furnaces, and refining it into high-quality steel. Recycling iron reduces carbon dioxide emissions by 60% compared to producing new steel from iron ore. The recovered steel is used in construction, infrastructure, and manufacturing, contributing significantly to the circular economy. Recycling ACSR cables. ACSR cables, which combine aluminum conductors with steel reinforcements, are widely used in overhead power lines. These cables are recycled by separating the aluminum from the steel core using specialized shredding and sorting machines. The reclaimed aluminum is used in producing new conductors, while the steel core is melted down for use in various industrial applications. Recycling shredder wires and wire harnesses. Shredder wires are typically composed of copper or aluminum cores encased in plastic insulation. Recycling these wires involves mechanical processing to separate the metal from the insulation, yielding high-purity copper or aluminum. Wire harnesses, often found in automobiles and machinery, are processed similarly to recover valuable metals and reduce electronic waste. Optical fiber and Cat.5 cable recycling. While traditional copper cables dominate the market, optical fiber cables are increasingly replacing them in high-speed data transmission. Optical fibers, made of glass or plastic, require specialized recycling methods. Though they do not contain metals, the associated connectors and casings often include copper or aluminum, which can be reclaimed. Cat.5 cables, commonly used in networking, contain significant amounts of copper and are processed for recycling in specialized facilities. Christmas tree lights recycling. Old Christmas tree lights are a common source of recyclable copper. These lights consist of copper wires covered in plastic insulation and tiny bulbs. The recycling process involves shredding the lights and separating the copper from the plastic. The recovered copper is sold as scrap, while the plastic is either recycled or disposed of in an environmentally friendly manner. Screen replacement on BDR 1245 and BAT 800. BDR 1245 and BAT 800 are specialized machines used in the recycling of cables and wires. Over time, their screens wear out and require replacement to ensure efficient separation and granulation of metals. Screen replacement on these machines is essential for maintaining productivity and ensuring the purity of the recycled metal output. Electric motor recycling machines are engineered to recover valuable materials like copper and aluminum from discarded electric motors, which are typically encased in tough shells of steel, cast iron, or aluminum. These sturdy casings protect the delicate internal wiring and components, making the motors appear impenetrable. The recycling process requires rugged, specialized equipment capable of dismantling these casings and extracting the valuable materials within. The process begins with the motor being securely positioned in the machine. The equipment uses powerful cutting and crushing mechanisms to split open the outer casing. Once the shell is breached, the machine separates the internal components, including copper windings and aluminum parts, from the steel or other materials in the casing. This step ensures that the valuable metals are preserved without contamination or damage. Next, the machine isolates and collects the extracted metals. Copper, being one of the most valuable materials, is carefully removed and prepared for recycling. Similarly, aluminum and other reusable components are segregated for further processing. The remaining materials, which may include non-recyclable waste or less valuable elements, are discarded appropriately. Designed with durability and efficiency in mind, electric motor recycling machines are user-friendly and built to last. Their ergonomic working height enhances operator convenience, while safety features ensure secure operation. These machines are also portable, making them easy to relocate as needed, whether for industrial recycling centers or smaller-scale operations. Manufactured in South Korea, this equipment represents a significant advancement in recycling technology, enabling the recovery of critical resources from discarded electric motors. By transforming waste into reusable materials, these machines support sustainable practices and contribute to the circular economy.